Hello, students. Uh, this lecture is about 3.11 user-defined data types. Since it was the first chapter, we missed it out early because I wanted you to know everything before we get into this chapter so that you could reap the essence of this chapter as much as you can. As one of the most first chapter, usually we don't pay any heed to the importance of chapters sometimes. That's why I actually advised and tried to teach it towards the end. Anyways, this chapter requires you to show understanding of why user-defined types are necessary, define and use non-composite data types, which are enumerated and pointer. Non-composite data types are those which do not make use of other data types. Like we have primitive data types that string, character, date, time, boolean, integer, real. Such data types are raw themselves. They do not require anything else. So non-composite data types are that sort. Uh, these are used for special cases. The other one are composite data types, which make use of other data types. Like that type and type, record and record, which is a record data type in classes and objects where there are multiple methods and data which are being used. So those data types which are user defined because intrinsic or primitive data types, they do not fulfill the purpose. There we use composite data types. And then we are expected to choose and design an appropriate user defined data type for a given problem. So let's start. Key terms that we have to have are 3.1.1 user defined data types. So key terms that we have to understand by the end of this chapter are, first of all, user defined data type. So user-defined data type is a data type based on an existing data type or another data type that have been defined by a programmer. So when original data types don't work, we make use of user-defined data types. Non-composite data types. Non-composite data types are the data type that does not reference any other data type, as I explained earlier. Then enumerated data type. A non-composite data type defined by a given list of all possible values that has an implied order. For example, like we have got grades: A grade, B grade, C grade, D grade, E grade, and then U grade. So this collection would be called enumerated data type, or A quality, B quality, C quality, and that's it. This is enumerated data type. And then we have got pointer data type. A non-composite data type, this is like by ref in functions calling or procedures calling. When we call subroutines and we transfer the address of the variable rather than the data itself, it is called pointer. So a non-composite data type that uses the memory address of where the data is stored. And then we have a set. All right, a given list of unordered elements that can use set theory operations such as intersection and union, as we do in mathematics. So let's start. Programmers use specific data types that exactly match a program's requirement, but sometimes it is not possible. So programmers define their own data types based on the primitive data types. Primitive data types are string, character, date, time, boolean, integer, real, and currency. Uh, Sometimes they use data types that they have defined previously in a program. So I told you that from one UDT you can create another UDT as well. Uh, Such type of efforts are called user-defined data types. So let me revise. Programmers use specific data types that exactly match a program's requirement. They define their own data types based on the primitive data types provided by a programming language, or data types that they have defined previously in another program. These are called user-defined data type. User data types can be divided into composite and non-composite data types. So types are composite and non-composite data types. So let's start with the non-composite data types. A non-composite data type can be defined without referencing another data type. It can be a primitive data type available in the programming language or a user-defined data type. Means string, character, date, boolean, integer, real, currency. They are non-composite primitive data types. Or it can also be. Now the thing is that until now you have learned that how the user data type is making use of other data types like in record and type and end type thing, but sometimes it is possible that we create a data type which is never made before, and it is only the data type which you are creating and it is not referencing to another data type. So let's see how. Non-composite user data types are usually used for special purposes, obviously the purpose which is related to the given scenario. We will consider enumerated data types for lists of items and pointers to data in a computer's memory. So let's see enumerated data types first. An enumerated data type contains no references to other data types when it is defined. In pseudocode, however, the definition for enumerated data type has this structure. We call it type, then we put identifier name, and then we tell that what values are there. Value 1, value 2, value 3, and so on and so forth. For example, the data type for months of the year could be defined as this. This is syntax. This one is syntax. Now this is how we define it. Let's say type, the name of this type month. Remember, month is a keyword, so don't use that way. So Jan, Feb, March, April, May, June, July, August, September, October, November, and December. That's my data type, T month. So this is data type, not the variable itself. So this name usually begin with T to aid the programmer type, and these values are not strings. So this is actually not the string, so mind it. Hold on. This is not a string, so it will not be enclosed in any quotation marks. Then the variable this month will be made. So we will be like declare this month as T month. So we will be like this month is equal to January. Remember not to put it in um, any quotation. Let's say another variation could be declare next month as T month as well. And we can write like next month is equal to this. Hold on. This month plus 1. So this would all automatically become a fab. So you need to understand that these are not strings, these are the values which are in order. So what I said that enumerated data type is a non-composite data type defined by a given list of all possible values that has an implied order. So it has got an implied order. So if you are making it +1, it means that whatever this month is, this next month will become the next month. So if this month is May, next month will become June automatically. So this is enumerated data type. Now pointer data type. A pointer data type is used to reference a memory location. You should always be considering in Visual Basic with reference, parameter transfer with reference, and with C language or Java, you should be remembering pointers when the functions are called. This data type needs to have information about the data type of data that will be stored in the memory location. It is not actually the data itself, it's just the memory location of it. In pseudocode, the type definition has this structure. We will use this cap as well. Uh, Cap shows that the type being declared is a pointer or so let's say what's the syntax? Type pointer is equal to cap and then type name. So let's have one example of it. We just had this T month. So we make it t-month pointer. T-month pointer is equal to address of t-month. And then we will be like, how do we declare it? I have lined up one past paper question for this as well, because you might have never come across something like this. So you'll be able to understand it better. Month pointer. Remember, this is paper 3 topic, so you would not have to program or anything. It's just for the reference, and any technical question shows up. So this t month is the data type in the memory location that is pointer that this pointer can be used to point to. All right. So it could be used as a month pointer is equal to this month. So if the content of memory location are required rather than the address of the memory location, then the pointer can be dereferenced. For example, means my month can be set like this: declare my month as t month, and then my month is equal to month pointer and cap. This is dereferencing, sorry. So using the cap afterwards is dereferencing, means month pointer has been dereferenced. Dereference means whatever the data at this location would be will be placed in my month. So month pointer is the address of this month. And if we dereference month pointer, the data at this location will go to my month pointer. So let's see first a past paper question so that you have a good idea of it. This is May June 17, question 1, part C. A pointer is a variable that stores the address of a variable of a particular type. Consider the code on page 3. This one, here's the code. Consider the code on page 3, which uses following identifiers: integer pointer, pointer to an integer variable, which is a variable temperature, no, sorry, temporary one is a variable of integer type, and temporary two is another variable. So this would have the address, integer pointer would have the address of the variable, and rest three would have their own data in it. So let's see how it works. So integer variable is equal to 57. So this integer variable's value is 57. Integer pointer is assign to integer pointer the address of the integer variable integer so let's do it once again. Assign the value 57 to the integer variable. Assign to integer pointer the address of the integer variable. So integer pointer would have the address of this integer variable. So what would be the value of integer pointer? This would be $8216, because this is the address of integer variable, and over here it says that the address of integer variable will be assigned to integer pointer. So integer variable's address is 8216, whereas over here it is being dereferenced. Assign to variable temperature to the value at an address pointed to by the integer pointer. So what is the value of integer pointer? That is 8216. And what is the value over there? 88. So what would be the value of uh, temp2? Temp2's value will be 88. This is dereferencing, that at this address, whatever the value, that will be assigned to temporary two variables. Assign to variable temporary to the value at an address pointed by integer pointer. So now temporary one, assign the value in the variable temporary one to the memory location pointed to at by the integer pointer. So at this address, this is dereferencing, the value will be placed. So what is actually happening? Let's check it out over here. So integer pointer is 8216. Now whatever that is at 8216 will be placed in temporary 2, that is 88. Now the value of temporary 1, which is the value of temporary 1. Temporary 1's value is 88. Will be placed at integer pointer location. So this 88 will also be placed there. So let's see what is the answer. So over here is at temp2, its value will be 6715. 6715 at temp2 means temp2's address here. 6715. Integer pointer, this was actually the address of integer variable, which is 6216, 6216. Sorry, this one is 8216. And then we have dereferencing of integer pointer, that will be 88, because now it is referencing to this at the address at 8216. And then we have integer pointer reference whatever the temporary plus temporary 2 plus 6. So what is temporary 2? 50 um, 7 and 57 plus 6 becomes 63, and def reference is actually 88, which is not 63. So the answer would be false. It is not being assigned, it is being checked. All right, it is being checked, so this would be false. Go further. Write down pseudocode statements that will achieve the following: assign the value 22 to the variable temp2. So temp2 is equal to 22. That is very simple. Place the address of temp1 in integer pointer. So this would be integer pointer is equal to at temp1. Copy the value in temp2 into the memory location currently pointed at by integer pointer. So integer pointer dereferenced means integer pointer cap is equal to temp2. That is how it will be done. So let's get back to the pointer slide. So that is how pointer is dealt. You people basically are required to visit this question back in 2017. All three variants would have questions of pointer. So there would be two different types of questions. So please solve those. Now, afterwards are composite data types. A data type that refers to any other data type in its type definition is a composite data type. Unlike non-composite data types that had their own data in it, where uh, we just had enumerations and pointers. These data types are referring to other data types. So let's have one. This is exactly the way we did earlier. Let's say we are going to form a type, a record type. So type book record. So this would have declare, as we already did in P4, declare title as string, declare author as a string, declare price as currency, and so on and so forth. Or over here, we will type and type. And then we would have a book declare Zach's book as tbook record. And then let's assign some data. Zach book dot title is equal to CS by Zach book dot author is equal to Zafar Ali Khan, and Zach book dot price is equal to rupees 30. It's a cheap book so that everyone could afford it. All right, all right. So we have already used it in P4 quite comprehensively. So move on. Now, classes. We already have done object-oriented programming, or if you have not, you would do in P4, obviously. So classes, a class is a composite data type that include variables of a given data type. And methods. So a class has a name, like I name it mammals. It has got a data that it run is a string. The way it moves, we need to classify that as well in it. No, let's make it mammal class as a string and a method which is run. That's better. Okay, a class is a composite data type that includes variables over here and methods over there. So this is class, this is variable, and these are methods. Methods are actually subroutines. And then from these classes, objects are formed. So let's say so if I like to make a working object of this class, I'll be like declare bet, and then bet is equal to new mammal something like this. So this will create a bet object, which is a working instance of mammal class in computer's memory. That is how classes are working. And sometimes another syntax can also be used, that is declare bat as new mammal with the value that we are going to um, send it to to instantiate itself. So that's about it. We don't have to discuss a lot of from the classes, just the definitions. Whereas in paper 4, we will be making more classes, or if you have an idea of it, we have already made several classes. So that's about it for section 3.1.1, user-defined data types. Uh, wait until the next lecture, hopefully tomorrow. See you then.